Hello, in this video, we're going to talk about a data structure called stack. So just like list and array, stack is a data structure, as we sort of mentioned earlier. Now, one thing I want to say is we're only going to cover how stack works and how to use it to solve problems. We will not go into the detail of its implementation, which will be covered in 3B. Okay, so what is a stack as a data structure? What is a data structure? As a recap, data structure is a collection of things, the relationship among them, and most importantly, the kind of functions or operations that can be done to the data that is stored in that data structure. So, what are the operations that we can do for a stack? Well, to answer the question, we kind of have to define the most important property of a stack, and that is that stack is what's called a LIFO. So what that stands for is last in, first out. So the thing that would put in last is the thing that would come out first. And that's really it. It's really that simple. However, it's incredibly useful. It solves many problems very elegantly, and we'll get to see an example of that in a bit. Now, so as we said, then the first thing we put in is the last thing that comes out. Then what kind of operation can we perform on a stack? Well, one operation is to put something in, the other operation is to get something out, right? So the operation that put something in a stack is called the push operation, and the operation that takes things out of a stack is called the pop operation. And these two must work hand in hand together to guarantee the last in, first out property of a stack. So let's take a very quick look at what it actually means. So let's assume we already have a stack and we have two numbers in there already, and then we want to put another number in the stack. So we do the push 18. So we take the number 18 and we push it on to the stack. Okay, now the stack have the number 18 on top of it. Now, so then what happens when we get something out from this stack? So we perform the pop operation, and a pop, it has to pop the value that goes into the stack last, which is 18 in this case. So we just take whatever's at the top of the stack and pop it out. And so now we return 18, and the stack is back to what it had before we pushed 18 in there. So that's really it. Push a number and then pop off the top of the stack. And if that looks kind of familiar to many things that in real life, that's because there are a lot of stacks in our lives. Right? A stack of paper, literally. This stack really kind of means what it means in English. A stack of paper, a stack of dishes. So let's think about a stack of dishes. How is that a stack? Well, when we want to put a dish on top of the stack of the dishes, well, we put that dish on top, right, on the very top. And then if we want to use a dish from the stack, we typically just take the one at the top of the stack of dishes and use that, right? So the last dish that we put on top of the stack is the first dish that we take off from the stack and to be used. So that's a very typical example of a stack. A two-car garage. And now this is not one of those garages where you park the two cars in parallel, right? This is a garage where you one car goes in, and then another car, the second car goes in behind the first car. So if you want to move a car out of the garage, then you have to move out the second car first, right? Otherwise, you can't take the car that's already that goes into the garage first. So you move the car that goes into the garage last, and you take that car out first. So that's another example of a stack. Okay, and then one more example for a stack. Think about the lines at Disneyland, right? People get into the line. The last person who get into the line is the first person to leave the line and get to go into the park. Or not. I hope you caught me on that, because a line is not a stack. We kind of all wish it were, but they were not. Okay. Obviously the last person that gets into the line will be the last person to leave the line and go in to the park. Or another way to look at it is, if you're the first one in the morning to wait in the line, that you will be the first one to get out of the line and go into the park. So that's actually, a line is an example of a FIFO. Okay, first in, first out, and that is called a queue. That is not a stack. Okay, we also have the stack is also used in many software applications. You've been using that many times already. So, for example, all of us browse the internet using browsers. Browser history is a stack. Let's see if I have browser history somewhere. Browser, wait, where's my browser? Oh, here. My browser, pick this up. Okay. All right, so I'm just reading some Python books. I'm looking at whatever chapter 3. Now, if I go to chapter 4, okay, chapter 3 actually got pushed onto a stack. And then I go to chapter 5. What I was browsing, chapter 4 before that, also gets pushed onto a stack. And then if I go to 6, 5 gets pushed onto a stack, so on and so forth, right? So when I want to go backwards from 6, the first one I go back to is 5. And so that chapter 5 gets popped off the top of the stack. If I want to keep going back, I will go to chapter 4, which was pushed onto the stack before chapter 5 was. And then 3, and so on and so forth. So that is also an example of a stack. And what other examples do I have? Okay, yes, the editing history, right? If you type the letter A and then B and then C, if you undo it, you undo typing C first, and then undo typing B, and then undo typing A. That's also, kind of pushing things, pushing A, and then pushing B, and then pushing C on the stack. And when we want to undo, we pop C off first, pop B off, and then pop A off. So that's another stack. Finally, in programming, especially in computer science, stack is used in so many things. I really can't count all of them. I have some example here. Many of them don't make a whole lot of sense yet, but hopefully as you kind of move through your computer science programming education, you'll see more and more examples of using stacks. One thing that you might not realize is, actually in programming, you've been using stack all along. And that is when you call a function, or when you call a method. Calling function and calling a method actually creates what's called an activation record on a stack. I might try to explain that in recursion. We'll see. All right, so since stack is so useful, let's see it in action, right? So how do we use a stack? Well, it turns out stack is so useful, Python actually has a built-in type for it, and it is the list. And yeah, I'm not kidding. Even though it's called a list, it can do what a stack does, and that is why I've been saying list is just extremely versatile. And also another thing to know is that in languages like C, C++ or Java, stack is not a built-in type. But it's provided as part of a standard library, but it's not a built-in type. So the fact that Python has it sort of built-in, even though it's not called a stack, kind of is another reason that Python is so useful. Okay, so how do we use a list to kind of emulate a stack? Well, as it turns out, we already used the append method quite a bit on a list, right? So that puts an element at the end of the list. So append is equivalent to a stack's push operation. Okay, and lo and behold, list actually has a pop operation. The pop removes and returns the element at the end of the list that is put there by append. So basically, that is the same as stack's pop operation. So let's use that and see it kind of in action. So I've already typed it out here. Sorry, I kind of cheated, but anyway, so now let's take a look at this first. That I created a list called list 0. I put 3 in there, and then I put 100, and then I put 28 in there, and I print out the list. So when I run this, okay, what do we have? 3 is the first number we put in, 100 is the second, and then 28 is the last number that I pop. Oh, sorry, I push in, right? So this is the last number. So okay, so far so good. Now what happens when we do? Well, actually, let me just pop the last element of the list first, and I'll print. The pop returns the last element in the stack, right? On top of the stack. Actually, I really should call this a stack. Okay, anyway, think of this as a stack. So this should pop the last thing that I put in, which is 28. So let me run that, and there. So it pops the last element I put in. And if we want to see what's left in the stack, right? After I pop 28 off the stack, we have 3 and 100 left. And if we pop another one, that should now give me 100, and then 3 is the number that's left in the stack. So yeah, second time I pop 100, and then 3 is the one that's left. Like I said, really should call this stack rather than a list. Okay. All right, so that's really what these slides are trying to say here. Yeah, you kind of see it in action, and hopefully that all makes sense. Now it's your turn to try to do something slightly more complicated. So let's take a list of numbers. Let's call this list 0. And you can put whatever number in there, or what I'm going to do is I'm just going to put 0 through 9 in there, okay? Take each number off this list and push it onto a stack, okay? And then let's pop all the numbers out from the stack and insert it into a new list, list 1. So, and then let's print out what list 1 is. So basically, we push all the numbers from list 0 into a stack and then pop them out into another list, list 1. And then I want you to compare list 1 against what's in list 0 and see what happened to those numbers. Okay. And now you can do this with a loop or with maybe 2 loops. Okay. And as a bonus, try to do this with list comprehension. That would be fun. So yeah, instead of using loops, try to do this with list comprehension. But if you can't get there in one try, do it in a loop first, and then try the list comprehension way. Okay, so pause the video, give this a try. All right, so assuming you've done that, I hope that was sort of an interesting exercise. I am going to try to type this on video, and let's hope that I get it right. All right, so I already have kind of a starting code here. So I just have my list 0 is just numbers from 0, 1, 2, all the way to 9, 10 numbers. Okay, I'm going to try to just use the loop. So for number in list 0, okay, I'm going to create a stack first, but it's just a list. Okay, so for all the numbers in list 0, I'm just going to put them or push them onto the stack, all right, and n. And then I'm going to actually print out stack 0 and stack 0. Hopefully I have it right. Let me run this. All right, there we go. Well, I have I successfully just kind of push all the numbers from list 0 into stack 0. Okay, no surprise there. Now I am going to have the list 1. I'm going to start with, again, empty list. Now I am going to pop everything from stack 0 onto list 1. Now, how many times am I going to pop? Well, I'm going to pop as many times as there are elements in stack 0. So what I'm going to do is I'm going to say for just, so I don't really care about the index anymore, right? Because stack does not have an index, right? Remember, stack only has push and pop operation. So I don't care for an index, but I'm going to try to do it. The number of times I'm trying to do it is equivalent to the number of elements in the stack. So the length of the stack, and I'm gonna insert. Okay, I'm gonna insert the thing from stack 0, and I'm just gonna do a pop. Okay, and hopefully if I get it right, I'm gonna print list 1, and list 1. All right, moment of truth. Okay, so that's that. Now, I asked you to actually look at compare list 1 with list 0. What do you see? Well, they have reversed, right? And why is that? Well, when you think about it, when going from list 0 to stack 0, we take the first number, push it into the stack, take the second number, push it into the stack, so on and so forth. So list 0 and stack 0 would look exactly the same, right? Now, from going stack 0 to list 1, we pop off the stack. The first number we pop off the stack is 9. So we insert 9 into an empty list 1. Okay, and then we pop this from the end of the stack, which now is 8, and we put 8 into list 1, and that's how we end up 9 and 8 here. And then we keep going backward. We're popping from the end of stack and inserting that in order back to list 1. So stack, one thing that you can see is stack actually has the effect of reversing things. Okay, so I hope that makes sense. And yeah, I also have the a solution with the list comprehension. So so give that a try. Give that a try if you haven't already. And once you're done, you can compare with my solution in the next slide. And here's a solution using list comprehension entirely. And you know what? I will just do it here as a demo. Okay, so I'm going to be using list comprehension. Now this first for loop, so I start with an empty stack and I take what I want to do and put it in a list comprehension. That's that, right? Hopefully, yeah. Oh, wow. I should print out the stack here. Yep. Now, if I do that right, I should at least have, yeah, stack 0 the way it was. Now, the next thing that I want to do is actually convert this to a list comprehension. And because I'm basically just popping things from the stack, then all I have to do is to pop things from the stack, put everything I pop off from the stack into a new list and assign that new list to list 1. And I think I did that right. Let me run it. And there. Right. So that's how how to use list comprehension to do exactly the same thing as what we did with the loops. Okay. So hopefully that's helpful in your understanding of stack as well as list comprehension. I think that's the end of this video.